But yeah, thank you, Nicholas, and hello, everyone. Good morning, afternoon, evening, depending on where everyone is. As Nicholas mentioned, I am a faculty member at Pennsylvania State University's campus in Erie. And the work that I'm going to present today, this was one of the projects in my doctoral dissertation. Matt Beckman and Carrie Lockmorgan were my fantastic advisors who are now co-authors. And this conference is a really great segue. I'm just finishing up my first year of teaching. So going from the practice of statistics education back to thinking about the research is very helpful. And just to provide a little bit of context, my background is in statistics. I pivoted to statistics education only in the last few years. And I did my doctoral work here in the United States, but my undergraduate training was back in India. So I'm hoping that some of the conversations in this conference help me think about statistics education research sort of more holistically, both from a disciplinary as well as location point of view. And that's already been happening in the last few years, last few hours, I apologize. All right, so as I begin my presentation, I want you to take a second and take yourself back to sort of the end of year 2020 and early 2021. Because in this work, we are thinking about statistical literacy in the context of the COVID-19 pandemic. So that's the time frame in which this work was conceived and conducted. We're going to begin by looking at a question that has to do with hypothesis testing, something all of us would be familiar with. The question states, an electrician tests whether or not an electrical circuit is good. The null hypothesis is that the circuit is good. The alternative hypothesis is that the circuit is not good. And the electrician performs the test and decides to reject the null hypothesis. And this question is accompanied by the four alternatives that you're seeing on the screen towards the bottom of it. The respondent is asked to choose the true statement. The circuit is definitely not good and needs to be repaired. The circuit is most likely not good, but it might be good. The circuit is definitely not good and does not need to be repaired. And the circuit is most likely good, but it might not be good either. Right, so these are the options that are presented for this item. We don't have to try and answer the question, but with this in mind, I want you to now consider the following test. A procedure called the RT-qPCR tests whether or not a wastewater sample is positive for the COVID-19 virus. The null hypothesis is that the sample is negative. The alternative hypothesis is that the sample is positive. The lab performs a test and decides to reject the null hypothesis. The source is CDC, which is the Center for Disease Control in the United States. Now, you might have noticed that both of these items look very similar in their structure, and we are going to talk about that. But the key piece I want you to think about here is that very few people, at least the ones I know, think this carefully about electrical circuits. I mean, I'm a very responsible homeowner and a statistician. So the first data point I get that something is not working, I flip the switch very quickly a few times and I say, all right, got to call an electrician, right? That's the extent of data collection I do there. But on the question of testing for the evidence of COVID-19 virus, the CoV-2 SARS virus in wastewater sample, and again, we're thinking back to late 2020, early 2021, I am much more engaged, interested, and would consider this to be relevant to my life. And maybe some other people in the room would agree with that. Both of these items, they're functionally the same. They're trying to measure the same learning outcome, but it's possible that they engage the respondent differently based on the context of the question. And that right there is the central topic of the work that I'm going to discuss with all of you today, the relationship between statistically literate behavior and contexts. And specifically, I am asking the following question. Can we assess contextualized statistical literacy? What do I mean by contextualized statistical literacy? It just means statistical literacy in relevant contexts. You might ask, what counts as a relevant context? We are thinking of relevant contexts as contexts that are societally relevant at a given time. So there is a broad scope, there is a temporal relevance there, and it's something that the respondents would have engaged with and thought about on their own, outside of the statistics classroom, outside of these discussions. And just to make sure we are on the same page, we are using the definition of statistical literacy that has been specified, that was specified by Laura Ziegler, who was at the University of Minnesota. And this definition states that statistical literacy is the ability to read, understand, and communicate statistical information. Now, just to look at the big picture for a few minutes here, statistical literacy has obviously been discussed extensively in the stat education literature. I've put down two definitions here just to sort of think back to some of the earlier definitions versus some of the more recent ones, but there's been a broad range of work that has been conducted in this space. And it's not only statisticians and stat education experts who are talking about this. Larger agencies such as the American Statistical Association, the World Bank, the United Nations, they've also talked about the importance of statistical literacy in citizenry. And in these discussions, statistical literacy is talked about from various perspectives. Statistical literacy is discussed as a learning outcome for stat education. Curricular approaches for improving the statistical literacy have been proposed. There are multiple assessments of statistical literacy that are out there. But when we look at all of these discussions, the common theme that emerges is that statistical literacy plays a critical role in promoting a citizenry that is more capable of understanding the world around them and making evidence-based decisions in their private and public lives. So we really are thinking about statistical literacy in people's individual lives. It's also important to remember that we are thinking about the practice or application of statistical literacy in people's individual lives. On the learning side of things, I should be upfront and acknowledge that there are varying views, not all of which agree, about the role of context and how it affects the transfer of knowledge therein. But no matter what we believe, these literacy skills are being applied in contexts that the individuals consider relevant. All right. So with all of that being said, in this project, we developed and piloted an assessment that measures statistical literacy in a relevant context. So it measures contextualized statistical literacy. And the context we look at was the COVID-19 pandemic. We used a research-based assessment, which was the Basic Literacy in Statistics assessment developed by Laura Ziegler again. We picked this because of two reasons. Well, two main reasons. One is that it focused solely on statistical literacy. If you think about statistical literacy in the framework of statistical reasoning thinking, this assessment focused only on the literacy skills. And it was developed for an introductory statistics student who has studied under the simulation-based inference curriculum. And that was the population that we had the best access to. After modifying the assessment, we gathered evidence of reliability and tried to develop a validity argument using expert feedback, think aloud interviews, and pilot study. So these are the two components that I am going to talk about in the rest of my presentation, the development and some of the insights that we were able to draw from the initial study. Just a little bit more about the assessment itself before we go forward. This assessment included 37 items, each with an individual learning objective, so 37 learning objectives, which spanned 9 learning goals, which are very typical of an introductory statistics course at an undergraduate level. Right. So first part, as I mentioned, was thinking about how the assessment was modified. And in addition to all of the sweat and tears and coffee that went into it, here was the procedure that we followed. This modified instrument that we piloted, it included 31 modified items, or 31 items that were isomorphs of the originals, and we retained 6 anchor items. Now, if you're wondering, the way I was when I first heard about the word, what is an isomorphic item? An isomorph, which is sometimes referred to as structural isomorph in some literatures, is an assessment item that's identical to a base item. So there are common structures, which includes the concept that's being assessed, the phrasing, as well as the distractors or the options for the multiple choices that are presented. And the only difference across the two is the context. So essentially, the isomorphic item is built in such a way that it is assessing the same learning objective as the original item. When we were looking at developing these isomorphs, we considered various aspects of the original item and tried looking for context, pandemic-specific context that would match the item. So we considered what are the types of variables and parameters that are being looked at. What was the type of sample? Was it an observational study versus or a randomized experiment? Whether the creation of the item required access to the raw data. Did I need to create a new histogram, or did we only need a summary statistic, or maybe we didn't need either? And finally, as much as possible, we also tried to match the topics. So just as an example, the original assessment had a question where the learning objective was understanding of p-values and how it leads to rejection decisions. But the original item had talked about a study in which dogs were trained to sniff a certain type of cancer. And we were able to find an alternative study where dogs were being trained to sniff the COVID-2 SARS virus. So that was a very useful and easy transition to make. Obviously, not everything went as per plan. There were a few items that we had to make some sacrifices on. We couldn't turn them into isomorphs as closely as possible. And in those cases, those were the items which were either contextless or they were the naked items, if you're thinking about it using the terminology in the gaze reports. They didn't have an obvious parallel. Sometimes they required access to raw data. And all of us who have tried looking for data sets, especially with quantitative variable available for all units, we know how hard it can get. And now we're talking within the first year of the pandemic and looking for raw quantitative variables on topics that were pertinent. That got a little bit hard. And finally, there were contexts where we were able to convince ourselves that changing something about the item, for example, the parameter that's being discussed, we had an example that was powerful enough that we were able and willing to make that concession. Finally, before I talked to you about the study and the data, the data we collected a little bit. As I mentioned, we decided to work with COVID-19 pandemic as the relevant context at the time. But that wasn't the only choice we considered. When we first started thinking about relevant context, again, societally relevant, given time, and something people would have engaged with on their own. There was a range of possibilities we considered, but we realized that the pandemic was too powerful a factor in the life of everyone to, it might be strange to say, but it was an opportunity that we wanted to use for the purpose of this study. But we recognized that the pandemic may have been devastating. It had a lot of negative effects on everybody's life as well. So to respect that part of it, we made sure that none of the items discussed severe illness. We didn't talk about loss of life or livelihood in the discussions. And we generally stayed away from any topics which could lead to an emotional impact. And there was the ethical side of it, of course, but there was also the measurement side, which is that we don't really have the tools to separate out the responses in terms of how they may be affected by statistical knowledge versus how they may be affected by people's emotional response to the context. So with that instrument, which we developed, the modified instrument with all the isomorphic items, we, as I mentioned, collected 3 sort of buckets of data. We reached out to expert reviewers and asked them to tell us, is each of the modified items comparable to the original in measuring the underlying learning outcome? We talked to a few respondents in the target population and conducted think aloud interviews. And finally, the pilot study was conducted in April 2021. We were able to send the instrument out to about 2,000 students. That's the enrollment of our undergraduate intro stat class at Penn State University. We offered it to them as post-test for extra credit. And because this was a pilot and because we were looking at this modified version of the assessment, we randomly assigned each respondent to complete either the original instrument itself or the modified version which we had developed. If I am focusing on the pilot study, of course, with the recognition that the expert reviews as well as think aloud interview played an important role in thinking about the reliability evidence, the validity argument, just the assessment response as part of it. We applied some item response theory tools with the typical methodologies to think about validity reliability. And we also applied some classical test theory tools, aka some regressions, to think about it from the point of view of student behavior and the differential performances on the 2 assessments. And of course, it's the same data set that we were looking at, but we were trying to frame our findings from the point of view of assessment comparison as well as student performance. Yeah. And the long story, okay, thank you. And the long story short here is the results were inconclusive, but they were promising. And I'm going to talk just in the last few minutes, I'm going to talk a little bit about just summarize those findings and what I mean by inconclusive but promising. So if we think about the performance side of things, what we're seeing on the screen are these overlaid histograms. The gray bars, first of all, these are total scores on the assessment, which was 37 questions, 37 points. The gray bars capture scores on the original, the BLISS, Basic Literacy in Statistics instrument. And the orange, yellow bars are capturing the modified version, the one that we were testing. And in terms of overall scores, we thought that the respondents on the 2 assessments performed comparably, but there were a few items that we did modify where we could see fairly large differences in how many people were able to answer it correctly. So that's something that went on our list of things to look at more closely. Thinking about it from a more measurement point of view, even if the relevant context didn't improve total literacy scores systematically, I think when we looked at things such as these item information curves, the overall curves, and the factor loadings, we felt optimistic that this isomorphic assessment could measure the same learning goals to a certain extent. Of course, it wasn't perfect, but we were able to reaffirm that we were measuring the same goals for a lot of the items, if not for all of them. And then finally, as I mentioned, we also looked at some, the assessment was also followed by a couple of survey questions. We wanted to gather some covariates about the students. And on this screen, I'm just showing you one of the survey questions we had asked them. We had asked them to self-report their engagement, interest, and sense of relevance vis-a-vis the pandemic. We did notice that a few covariates did show some relationship with the differential performance across the original and the modified instruments. So now we're looking at a combination of assessment-specific features, which we could potentially address. Hang on, let me just talk about that on the next slide here. But essentially, there were assessment-specific features and student features, which may have come together to show some of these differential performances. And in just the last 2.5 minutes I did want to take a step back in terms of research, in terms of taking this work forward. There were a few factors that we identified as things we maybe need to look at. Reading burden of items, definitely incorporating some of the more relevant context meant we had to explain some things, and that sometimes led to longer items. We might have been using slightly more technical terms. That's something we want to look at. This was just one context. And even in the 2 years that have passed since we piloted this study, we might be able to argue that the pandemic-related contexts are not as relevant today as they were 2 years ago. And this means if the larger idea is to ask ourselves, can our student take the statistical skills we hopefully impart to them in the classroom and apply them to things that matter to them outside of the class? Maybe the version we have is already redundant. So thinking about ways to keep incorporating these relevant contexts, maybe potentially fine-tuning the instrument so that we can keep testing this. That's one thing that we want to look at. And of course, we only had access to one population, which is undergraduate students at Penn State University who are taking the intro stats course. Generalizability can be questioned here. So those are some of the things that we want to think about. And I know that I only have 5 minutes left. If you just give me 1 minute, this is the last slide. Obviously, I came into this field, started thinking about stat ed research because I was passionate about teaching, and my hope is any research I do can help me go back to the classroom and do something better. So 3 things that I would mention are incorporating carefully developed research-based assessment can become a part of regular course cycle. It helps the researchers gather more data, and it also helps the teachers assess their students on an ongoing basis. Including relevant context in the classroom can provide valuable learning opportunities. This is not new to us. We have heard about it before, but a useful reminder nonetheless, hopefully. And lastly, when talking about relevant context, there's always going to be a need to balance the cognitive and emotional elements, and that's something that we need to be mindful about. All right, thank you very much, and I am happy to take questions.